to the webinar Recovered Carbon Black in Rubber. So the agenda for today, we have 1 hour for the presentation, but anytime you might need and want for questions, we'll see how the time pans out. I'll do a quick introduction. We'll talk about the latest and greatest about recovered carbon black, definition, process, composition, analysis methods, specification. There were some changes recently. Regulation is very important, especially in Europe. The paradigm change of the industry, and then we'll dive into rubber applications, which I have structured in tire applications and MRG, mechanical rubber goods, so non-tire rubber applications. And then we will do questions and answers. Introduction. So first of all, who signed up for the webinar? I always find that interesting to show to you. We should have had 3 gentlemen from Recovered Carbon Black, all 3 actually from India, High Green Carbon, Ratre, who both are one company as of my understanding, and then Royal Carbon Black, but somehow they didn't make it into the Zoom meeting. Maybe they are in on my website. So if any of you watches on the website, please come in the Zoom meeting if you want to ask direct questions. We're in the Zoom meeting because we're not so many people, and it would be nicer to have that Zoom meeting. We have Solvay, manufacturer of precipitated silica, and I believe the inventor of precipitated silica with first application Michelin in 1972, if I'm not wrong. We have custom compounding, Cluit, and we have Etra, Jean-Paul Boissy. Jean-Paul actually is one of my mentors as well when I started in 2015 and went to the European Tire Recycling Association. By the way, please could you all mute for the time of my presentation? Many thanks. And we have Weibold Consulting, doing tire recycling consulting since '99, much longer than I did. It's not Robert, it's Klaus, who is very experienced in the industry and who built up an Austrian tire pyrolysis company. Okay, so enough about the audience, a little bit about me. So I'm doing 8 years of consulting, mainly focusing on recovered carbon black, and I'm focused on tire-to-tire recycling. Recently on the ETRA conference, I gave the reason why I think really tire-to-tire is the only true circular business, and also many of the smaller rubber parts you can't go into a second loop because only the tires are big enough to be collected and recycled again. Also alternative carbon blacks. This morning I did a video presentation at the China Carbon Black World and presenting about sustainable carbon blacks, including circular, renewable, methane pyrolysis, of course recovered carbon black and carbon conversion carbon black. I founded with Smithers the Recovered Carbon Black Conference in 2019. Last year we had 260 participants, which I think is a strong message for the interest for recovered carbon black. And I'm working with most of the top recovered carbon black producers, and I'm in contact with almost all of them, working with brand owners like Decathlon, Mitsubishi, BASF, Michelin, Bridgestone, Trelleborg, Hutchinson, and more. I realized technology is not the main thing in making the world better, but it's the human element. So I'm also a certified coach specializing in sustainability and climate conscious coaching. You might have seen videos or anything from me on LinkedIn, and my motivation is to document the tire-to-tire recycling industry and recovered carbon black. My background, chemical engineering, but I also spent long time in titanium dioxide, custom color master batch, plastic master batch that is, and carbon black. So let's talk about recovered carbon black. And let's talk about the definition, because the definition is not very straightforward. For carbon black, furnace carbon black that is, we have the terminology relating to carbon black. And we have a couple of keywords which are highlighted. It's an engineered material, and the engineered really is very important to me because so it's not a material that comes out of the reactor by coincidence. We have elemental carbon, thermal decomposition, aggregates of a certain aciniform grape-like morphology. We have spheroidal primary particles. We have uniformity of the primary particle size. And we have turbostratic layering. We have this classification system for the furnace carbon blacks, which we don't have yet for recovered carbon black, and I'll get to that in a moment. And there's really two target values that classify the furnace carbon blacks, and that's on the one hand side the iodine adsorption. That is an old test method which is no longer used that much because it can be tricked by the surface groups on the carbon black. Nowadays, people use the BET, Brunner, Emmett-Teller nitrogen adsorption to tell about the specific surface area. And we got the oil absorption, which is a measure for the structure of the carbon black. And then, depending on those two, we have all the carbon blacks defined. Now, if we look at different sustainable carbon blacks, so the circular, renewable, methane pyrolysis, and recovered carbon black, it's very evident that recovered carbon black falls short in a couple of those. So it's not made by thermal decomposition of the hydrocarbons, but this thermal decomposition of the hydrocarbons releases or recovers the recovered carbon black material out of the pyrolysis. Also, we don't have aggregates of aciniform morphology. Very often we have, in fact, the opposite of it. We have like a sponge-like microscopic picture, which is due to the carbonaceous residues surrounding all of the recovered carbon black. And then we have the gas exiting in the pyrolysis, this kind of sludge, and it solidifies, and that is our recovered carbon black. So we have the inverse of grape-like, we have like a sponge-like very often. Plus uniformity of primary particles. We don't have that because recovered carbon black, as we will see in a moment, is a mixture of carbon blacks plus some other material. Now we have the same document for recovered carbon black, the standard terminology relating to recovered carbon black. And so we have thermal decomposition from rubber goods, not of rubber goods, which contain carbon black, which is free of wire and fabric, of course. And when milled, typically gives semi-reinforcing properties in rubber. That is all true. In the discussion, we also see it's containing inorganic compounding ingredients, which is the inorganic material in the tire, such as zinc, such as sulfur. We have an interesting work item, the ASTM work item 84831, which is for ballot in December 2024, which is the recovered carbon black classification. So it's a similar classification as we have for furnace carbon blacks. And the most important thing, ASTM says we only accept ASTM methods for that classification. And these methods can be either from the committee D36, recovered carbon black, or D24, which is the furnace carbon black committee, or the D11 committee, which is the general rubber committee. Here is my improved definition based on that, because for me it's really important to stress recovered carbon black needs to be an engineered solid product recovered from a selected end-of-life tire feedstock. That we'll talk about when we get to the RCB rubber call to action by Michelin and Bridgestone, where they really stress that the product is defined by the end-of-life tire feedstock. Pretty much like, engineers say garbage in, garbage out. If you don't control the feedstock and we have just any kind of tires going in the pyrolysis, we cannot expect recovered carbon black. Then we have carbon blacks. We have a small part of inorganic matter. Kirid, please can you mute yourself for the presentation? Shailesh, nice having you join. We're already in the presentation. Please, could you mute yourselves? So the pyrolysis process contribution is to minimize the volatile or the solid carbonaceous residues. Then we need to mill under a certain particle size. D97 means 97% of the particles are below 10 micron. And to have the uniformity of the macroparticle size. So we cannot control the primary particle size of the carbon blacks, we can only control the macroparticle size. And then of course we need to pellet, and typically the pellets are less than 2 millimeters. So that's an attempt by me improving the standard terminology relating to recovered carbon black and getting a little bit more into a product paradigm. We'll talk about that a little bit later. Let's look at the production process. And again, I see a three-step process for the production of recovered carbon black, where in the past, maybe people have seen the pyrolysis as the main process. I already got some comments on my presentation at the ETRA conference where I said, look, the pyrolysis really doesn't contribute that much to the quality of the recovered carbon black. It doesn't when you look at this process scheme. For me, the process for recovered carbon black starts with the selection of the tires. Then we have, of course, the pyrolysis, and then we have the post-processing, which includes both milling and granulation, and also the taking out of the remaining steel particles by magnetic means. Why is the end-of-life tire selection, the feedstock selection, so important? So here I'm comparing car tires and truck tires. These are new tires. Of course, the tires we get, end-of-life tires, they are used, so their tread is worn down. Typically for a car tire, we can say about 10% of the tire has been lost, which raises another problem, which is not actually a part of this webinar, but you might have heard about the discussion about tire and road wear particles. That rubber needs to go somewhere. But generally, if you look at the new tires, this is the composition, and it's quite different between car tires on the left-hand side and truck tires on the right-hand side. The car tires have more synthetic rubber, the truck tires have more natural rubber. Car tires have less steel, truck tires have about double the steel, but car tires also have textile reinforcement, what the truck tires don't have. Car tires have a little bit less of carbon black, and the main reason is actually the silica industry, because silica will talk about the magical triangle of tire performance in a moment. Silica in the tread has replaced carbon black because of its higher performance in two of the key performance criteria. So we have 8% or more silica in a new car tire. My analysis on the crump of used tires already is 7%, so we can expect in a new tire much more than 7% and much more than 8%. Of course, we got other additives. We got the activator zinc oxide, which should have been reacted to zinc sulfate. We might have some free sulfur as well. This shows you the different composition of car and truck tires. Of course, there is different compositions between the summer and winter tires, different types of SUV tires, performance tires. And the reason I'm showing this is we need to feed the pyrolysis with a consistent composition. So we need to control the tires. And the easy way of doing it is controlling the type of tires. And then it gets a little bit deeper. For example, Black Bear Carbon, the recovered carbon black maker in the Netherlands, has a patent for sorting the tires by measuring the silica content with an XRD, so X-ray diffraction method, in order to really narrow down the compositional feedstock into the pyrolysis to have a very, very consistent recovered carbon black. So this is the recovered carbon black production process. It starts on the left-hand side. It's quite complex, and this is the topic with many new people in the industry. Very few people understand the true complexity, and even this process scheme is a simplified process scheme. So we need to select the tires. We go in a multi-step granulation. The trend is to smaller and smaller granulates because that increases the surface area of the rubber. Rubber is an insulator. Most of the pyrolysis reactors are heated from the outside, so we need a long time to heat the rubber. Microwave pyrolysis that could heat the rubber granules from the inside is not yet that much developed. And then we typically have a mass balance. We get in gas out and we get the solid out. The gas typically is some 60%, and the raw recovered carbon black, the solid, is typically some 40%. Then when we follow the gas stream, the condenser really is important for the pyrolysis. And the condenser separates the condensable gas from the non-condensable gas. Plus also, the condenser is key because it tells the sulfur where to go. If the sulfur goes in the gas, we have a low sulfur oil, which means the oil is a very high value oil. And if the sulfur goes in the oil, then of course the oil pricing is a little bit more inferior. Typically, if you have 10% gas, we're talking about a self-sufficiency, meaning that we can heat the pyrolysis kiln with the pyrolysis gas. And then to be clean, we also have to, if we burn the gas, we have to go in the scrubber to take out any sulfur components from the gas combustion. Then on the recovered carbon black side, metal separation, we need the milling. Then we would go into wet granulation, just like furnace carbon black. We go into drying, which is actually one of the big cost factors in the whole process, to dry off the water from the 50% moisture containing wet pellet. Then we go into sieving and storage, and of course over and undersized pellets need to go back to milling. Interestingly, so the keywords engineered materials really for me starts at selecting the end-of-life tires. We have the thermal decomposition, we have raw recovered carbon black, free of wire and fabric. The fabric typically is decomposed in the pyrolysis. Then we need to mill for the uniformity of aggregates. This is not the primary particles uniformity, but the uniformity of the particles of the raw recovered carbon black. Just a quick throw in, because we're talking about processes and producers. So in here we have some representatives, as mentioned, from the Indian recovered carbon black industry. There's not a lot of producers right now, a lot of technology companies with very limited, please could you mute yourself, very limited production volume available. How could the industry scale up look like? This is an old slide from last year from the report Prospects for Recovered Carbon Black that I do with Notch Consulting. We're doing the new edition this year, but really the volume stays about the same. We just changed the major factor is the industry is like 6 to 12 months late. So the industry capacity will really be ramped up only in 2025. And as you can see, significant volume will come out of Europe, and that is based on the ecology paradigm, that is based on the sustainability credentials of the materials. Let's talk about recovered carbon black composition. This is also an old slide. In fact, we showed this with Peter Tehar back then at Pyrolix at the Carbon Black World Conference 2018. And again, the keywords, so we have the carbon black, we have the inorganic contents, and we have elemental carbon. And the feedstock really makes the mixture of carbon blacks and the inorganic content. I don't like so much the word ash, because ash is only after combustion. At that point in the recovered carbon black, I like to talk about inorganics rather than ash content. And then really one big topic for me at the ETRA conference was the pyrolysis is only really controlling the volatile level and the carbonaceous solid residues that are added to the recovered carbon black, and that inactivates the mixture of the carbon blacks we have in there. So both are really bad. And so I said pyrolysis is really contributing less than the feedstock selection to the recovered carbon black. Of course, some of the recovered carbon black producers, they didn't like it because they need to sell their pyrolysis technology. But when you think of the major components of recovered carbon blacks and the ash content really are governed by the feedstock selection. Now, one thing of worry, and that might be interesting for the company Solvay in this webinar, is the increasing content of silica expressed in the recovered carbon black as ash content. This also is an old chart, but it is from the Circtec presentation on the recovered carbon black conference in 2022 by Robert Harper last year, showing the increasing trend of silica use and the increasing trend of silica use in specifically car PCR tires. Analysis methods. So there's 3 types of analysis method categories I see. A full list you will find in the ASTM document 8466 of last year, carbon black test methods for testing recovered carbon black. I would see 3 major categories. The recovered carbon black industry, like the gentleman in this webinar, need process control tests. So this will be chemical compositional test for the consistency of the material. It might be physical and particle properties like the particle size to test whether the milling was sufficient. And really, the process control test is all about consistency. I call this the Starbucks strategy because you get the same quality of Starbucks all around the world, or you can call it the McDonald's strategy. You know what you get everywhere in the world, and we need to get to that performance level of quality control with recovered carbon black. Application tests, of course, are in rubber-specific applications, or if you look at plastic, what this webinar is not about, we need to test color and other things. And so we have the rubber statical testing, which would be the tensile strength, the elongation at break, the modulus 100, modulus 300. For the tire, of course, because we have a frequency in the load, we need the dynamical mechanical analysis. We get more into details of that in a moment. And what is important for people like me as a consultant, very often I'm sent samples of recovered carbon black and people ask me, okay, is this good? And maybe it's only 40 grams if I'm lucky. And then, okay, what kind of test can I do? So limited sample quality, very often for quick tests. But also if a tire maker or rubber company wants to test a material, what do they do first? So purchase a material reception income test. Of course, they probably will run a number of tests. What is the first test? Now, let's look at what does not work. Because for furnace carbon black, and we'll talk about furnace carbon black a little bit deeper in a moment when we get to rubber applications and what is required from a furnace carbon black that is also required from a recovered carbon black. For furnace carbon black, the rubber performance can be very, very well estimated, but just by looking at the structure and the specific surface area. So this is the performance landscape or the carbon black landscape of the oil absorption number over the statistical thickness surface area, which is the external surface area around the carbon black, not including the pores and the pore surface area. And we can see recovered carbon black typically would fall in this plot, would fall between a 550, 660 and a 330. And then people say, oh yeah, we're close to a 330. We should be able to replace 330 in a rubber. But that is the misconception. Then the rubber performance is either, if it is like a second grade recovered carbon black, close to a 700. If it is a better type of recovered carbon black, it's close to a ASTM 600 carbon black, which is also used in tires. So let's look at composition again and the test methods, which could be important. And this is a slide I also presented at ETRA. which led me to say that really there's only one test method missing for a complete toolbox of the D36 committee to do the classification. And I really think this year it could be nailed, or progress could be made on the classification system for recovered carbon black. Of course, somebody has to do the work. ASTM all is a voluntary work. And the tests really, now we can look at material by material. How do we test the fresh carbon, the carbonaceous residues, really by the rubber performance? And here we have a fantastic test developed by Continental Tire, by Jorge Pineda. This is the Fourier transformation rheology. It is accepted by ASTM. It is D8491. What do we do here? We test in the green rubber, so in the unvulcanized rubber, and we're looking at the response, the frequency response of the third wave, and we compare that to the base wave. And that gives a quick test. We only need 40 grams of recovered carbon black. We need to do compounding, so we might need a micro compounder to do a rubber recipe, but then we can go on this test, and I really like it for a quick test. Volatiles are a little bit easier to determine. If it is for the PAH, the polycyclic aromatic hydrocarbon content, we have the toluene transmittance D1618. We have the new thermogravimetrical analysis, the 8474, which is also great to tell us more about the ash content as well, or the inorganic content. Again, the type of mixture of carbon blacks we can determine also with the Fourier transformation rheology. And then we have only one missing factor, and that is a recovered carbon black put into the rubber cannot do its work if it is poorly dispersed. And the dispersion really is a very good correlation with the milling and the particle size of the recovered carbon black. The finer we mill, the better is the dispersion in a rubber compounding. One thing which is important also is in the rubber compounding, we really need the pellets. Tire companies, for example, like Pirelli, often say the fluffy, the powder, when they put it in the internal mixer, goes out in the degassing stage. And then it's not about dispersion, but it's about loss of the recovered carbon black in the recipe. And we don't have the required amount of recovered carbon black per the amount of rubber polymers. Particle size is by laser diffraction. It's a work item, but I think it will be going to ballot very, very soon. And so this is really the summary of the important analysis I see for the recovered carbon black to process control, to do the quick testing. We have the TGA, thermogravimetrical analysis. The only downside really is the small sample size. Going into the TGA are milligrams, and they need to be representative for maybe a truckload or maybe for a whole production run of a continuous tire pyrolysis. So sample taking and sample downsizing to make it representative for the material and the production run, that is really key. TGA takes about 2 hours, which is good, because if we use the ash content method, it is anything between 4 to 18 hours, so that's like an overnight test, depending on the sample preparation, which takes much more time. And then, of course, if you want to use that as a process control test, you're like 18 hours behind of your process, which is not so good. Toluene transmittance, quick test, very easy to do. Expected transmission for a good recovered carbon black is 80%. Really very good recovered carbon blacks are getting close to 99% transmission, which means that the toluene didn't extract anything meaningful out of the recovered carbon black that is hindering the light transmission. Meaning there's no or very low PAH content, which can be tested, of course, by gas chromatography and mass spectroscopy, but we won't do that as inline test or as a frequent test in the production. Then we have the particle size distribution test, which also gives us the D97, D50, D10, everything we want to characterize all the colloidal, the particle, physical particle properties. And we got the Fourier transformation rheology, which is an in-rubber test and indicates the carbon black mix and the carbonaceous residues. Specifications. So journey to specifications in 2021. I did a first try on specifications, and I defined RCB1 as the state of the art, RCB2 as like a second grade recovered carbon black. To me, it was very clear recovered carbon black raw is really not viable, at least not in rubber or plastics. Some companies sell it to the steel industry or sell it for thermal recovery. I also developed the concept of RCB0, an activated and functionalized high-performance recovered carbon black, which would come a little bit closer to the hard black N300 type of performance. Then, of course, last year, the RCB rubber group, Michelin and Bridgestone, did a great definition, a call to action, which was including feedstock, dispersion, post-treatment, and giving a suggestion for a COA, a certificate of analysis. So this is the document a supplier delivers together with the delivery of the product. Every batch has a COA, certificate of analysis. This year, I think we might have something from ASTM Committee D36, as mentioned. I won't go through details of my specification. For me, it was important to define and also to quantify consistency. And I looked at the process capability with a CPK value. Of course, the downside is only very few people, only very few RCB producers are industrial and have that data to actually prove that process capability to control the ash content to a CPK greater than 60%. 60%, that is actually based on true values I have from one manufacturer, but I think very few manufacturers are measuring the ash content or the inorganics content on a daily basis. There were a couple of other things, and of course it doesn't make sense that I have a specification and Michelin and Bridgestone have a specification, and maybe even ASTM D36 has a different specification. At the end, everything needs to come together, and we'll need to agree on a industry specification. Just a quick thing about RCB rubber. So that was the process. What did they do? We had an initial specification. I was luckily the consultant for Michelin and Bridgestone on that activity. And the overview and the idea was actually the tire companies copied the idea of having a standard dispersion and a high dispersion, which is the case for the precipitated silica for use in tires, where we have standard dispersion grade and the highly dispersible silica grades. Very often, silica dispersion is or has been in the past a problem, leading to the move at rubber compounding, tire compounding from tangential internal mixers to intermeshing internal mixers, leading the way to additives. But the highly dispersible silica is now the norm, and the tire companies like to have something similar for the recovered carbon black. And for the recovered carbon black, it could be as simple as a milling grade below 10 micron for the highly dispersible, and maybe 20 or 30, a little bit less for the standard dispersion recovered carbon black. Because I talked with one of those two tire makers about activated recovered carbon black, they like the idea of a special treatment and the combination of a highly dispersible recovered carbon black and activation to make it a little bit more reinforcing in rubber. And we got this kind of great proposal where you can note where the stable ELT feedstock is one of the discriminator. So the grade A1, 0.1, 0.2, 0.3 are all from a set mix of PCR, so car, TBR, truck, ag, agricultural, and OTR off the road. So, for example, mining or mining tires. But the mixture has to be consistent. And the grade B could be 100% truck, and the grade C could be 100% OTR. And that was just to give an idea about the feedstock governing the recovered carbon black product. COA, I won't go through all these items. They've been presented in the conferences. But of course, COA is quite elaborate, and we need quite a number of test methods for the COA. One part, and also last year, that was a striking development. Finally, we have a REACH registration. So REACH is the registration system for European chemicals, and that was done by Alpha Carbon in France and Circtec. Circtec are registered in the UK, I think, but they have a pyrolysis plant in Poland, and they're planning a big plant in Antwerp, I think, or Rotterdam. I might confuse the two. And the REACH registration is not under the name of recovered carbon black, but it's called amorphous carbon and silicon dioxide recovered from two-stage pyrolysis of spent tires. You got all the required numbers. It's quite elaborate. Actually, the process of participating in that REACH registration is you have to do a REACH inquiry dossier, proving what are the constituents of your recovered carbon black, and then if that falls close to what they have registered, then ECHA makes the connection to Circtec and Alpha Carbon for the participation of the REACH registration. Also, at the moment, because the biotoxicity tests have not been completed, the tonnage band is very low. I think it's up to 10 tons per year. So at the moment, we cannot industrially use the REACH registration, but it will be progressed to over 1,000 tons per year by the time Circtec plans to operate the big plant. In 24, 25, that we will have that required tonnage band. In the US, we have something very similar. We have the US TSCA. That's the Toxical Substances Control Act. And there's an anonymous registration for recovered carbon black in 2016. Not sure who that could have been, but there's not so many companies. It's really between Boulder Industries and Delta, and I don't think Delta launched this registration. Then, of course, we got the end of waste. And the end of waste for Europe is very tricky. Spain, Portugal, Italy, Austria have it. I think Klaus now at Weibold Consulting has done the work for Austria. And there's 4 criteria for the end of waste status. So we need a purpose, we need a market, it needs to fulfill the requirements, and of course it mustn't be harmful. But of course, now with the REACH registration, the end of waste could fall into place, because if you have a REACH registration, then you're talking about a product and no longer a waste. Now, other countries, of course, India might have different regulation of which are not knowledgeable at the moment, and so every country has its own regulation. The paradigm change really. The value driver for recovered carbon black. I will show you 3 value drivers. This is also an old slide, but in the Western world, the tire sustainability drives sustainable materials, of which recovered carbon black is one. And the second one is the low greenhouse gases, the low carbon dioxide emissions. And here we can see, this is also, by the way, an old slide, but I just like to show the carbon footprint of a normal internal combustion engine car, which is really where most of the CO2 emissions are in the use phase, which really led to the fuel-saving tires using precipitated silica as a means of achieving lower emissions. Now it has shifted a little bit, and the use phase of the tires for electrical cars might only be 60-70%. In my model, it is 66%. Now we have raw materials 24%, So tire makers cannot neglect the carbon emissions from the raw materials, including furnace carbon black, recovered carbon black, also of course precipitated silica. So companies delivering raw materials to tire companies, they have to do something on the carbon footprint. Production also increases from 3% to 7%, distribution from 0.6 to 2%. But really the main area where now tire makers try to improve on the carbon footprint is raw materials. Third driver, low PAH. There are specific low PAH furnace carbon blacks which are much more expensive than the ASTM grades, and recovered carbon black delivers that if the pyrolysis has finished, if the pyrolysis was sufficiently long and hot. We have a low content of PAH, which might actually also qualify you for food contact, but that is an entirely different topic. And so now we're really talking about a chemical production, delivering a sustainable material, delivering a low carbon footprint, delivering low PAH. So we're talking about a product focus, and this is the paradigm change. I question the pyrolysis companies whether they are a recycling business or a product business. And I invite pyrolysis companies to think of themselves not as a recycling business. Why is that? So in the chemical production, we have the needs of the customer, the tire industry, for example. With product focus, we need to fill specifications. We need a high level of control. We have high value. We are ecology driven. We have a high price as well. And we have a high value add, high compliance, which requires, honestly, quite a high level of investment, quite a high level of capital expenditure, CapEx. And at the same time, with all that investment, we need to keep the operating costs, the OPEX, operating expenditure, low. So that is very, very tricky. And but that is chemical production where we focus on the product and we work our way backwards. What kind of feedstock do we need? What kind of pyrolysis do we need in order to fill the specifications? And that is what I invite the pyrolysis industry to do. The recycling paradigm is a different paradigm, and we just take any feedstock, any tire. We don't control the type of tires going in. We have a low level of control. We might not actually fulfill the specifications of the tire industry. So it is a cost and economy-driven business. These kind of companies don't really invest a lot. You know, the refining line for recovered carbon black can be, a couple of millions, up to 5 million for a couple of 1,000-ton throughput. That is very, very expensive. Not all the companies in the developing world or in developing countries can afford that. So we have a low value add and low compliance. We have low CapEx, low OPEX, but also we're creating less value. So my paradigm is chemical production in my consulting anyway, but I think there's more value creation in the chemical production paradigm. Now let's go to rubber applications. Actually, we have already 44 minutes, and this is really the main beef of the presentation. I hope you have the time over the hour. Let's look at the rubber application market. In 2023, the rubber market for carbon black is projected to be some 12,000 tons. Sorry, I forgot to give the source there. That data is from my friend Paul Eiter at Notch Consulting, who's really the best in the market about anything carbon black data, pricing. And really, once we have that kind of data, we can slice and dice. Here in a pie chart, I want to show you 76% of the carbon black goes into tire applications, 24% in mechanical rubber goods or non-tire rubber applications, and we can see the segments here. We can also see the segments passenger car tire is a little bit bigger than truck bus tires. We have specialties, very small solid industrial specialty tires, including racing and mining tires. Mining tires really is a very regional thing. Big in Chile, for example, Australia and Canada, but there's almost no mining with trucks in Germany, are very, very small. Then the non-tire applications, we see extrusions, belts, anti-vibration, roofing, wire cable, and others. So let's look at tire. When you look at old cars, they have white tires, and the filler was zinc oxide. Now we're looking admittedly at Formula One tires. That is maybe the highest performance tire we can think of. What is the difference? It is the reinforcement of the carbon black. Back then, without any carbon black and also without any precipitated silica back then, these tires very often they didn't last longer than a couple of weeks. And every car had to have spare wheels and spare tires because it was sure that you would at one point stop in the road and have to replace a tire, which is no longer the case today. Even today, the spare tires are being economized from the car. Now we have the filler, the spray we put in the tire that is closing any damage to the tire. The magic triangle, this really is a success story of precipitated silica, and this is to show that the carbon black reinforcement is more or less mechanical, or mostly mechanical, by entanglement of the rubber polymer chains, whereas the silica silane system is a chemical bond. And of course, when you bond something chemically, the reinforcement can be much higher. The magical triangle says choose 2 out of 3, and maybe the colleague from Solvay can correct me. I think nowadays the magical triangle hasn't been quite broken, so if you optimize for higher rolling resistance and higher grip, we need to give in a little bit more in the wear or the abrasion resistance. I think personally precipitated silica have much improved, but might not yet been at the wear performance of carbon black. But the industry needs low rolling resistance so that the mileage for one battery load is optimized. Also, cars get stronger and stronger, and you need the grip on the road. Without the grip on the road, the car is just sliding, and the engine cannot transfer its power to the road. Furnace carbon black, I don't go through all of these slides, but basically the furnace carbon black is made in a furnace process from oil, and the structure of the carbon blacks really determines the mechanical reinforcement in the rubber. We have the classification, already talked about that. We have the landscape. Applications, so different furnace grades, different applications, and the smaller the end number in the blue box, the higher is the structure and the surface area, and the more reinforcement we can expect from that carbon black grade. So truck tread is among the highest reinforcements of carbon black. We get 100 type and 200 type of carbon blacks. In the passenger car tread, we have 300 type, but as I told you, that is or has been largely replaced, at least in Europe, now coming also in China and Northern America with silica. And the car cars, we would have 500 and 600 grades. Interestingly, the 700 grades are more like in the non-tire mechanical rubber goods. 900 is not from the furnace process, is used as a very large carbon black primary particle, which is used in anti-vibration. And now we want to understand a little bit more, okay, which kind of carbon blacks are used in which tire section. 45, this is the structure, or these are the detailed compounds of a car tire, PCR, passenger car radial tire. Some 45% is the tread. And the tread is structured again in cap, base, and shoulder. But basically, it's mainly 300 type of carbon black and silica. We have the sidewall, another big chunk of the tire, 24%, 500, 600 grade. And we have the inner liner, which is 16%, where we have the 600. And then it gets really small, and tire makers are reluctant to change much in the smaller compounds because the risk with the smaller compounds that the compound is not working for a very small amount of change in sustainable material is getting much too high. So we have the jointless bead, we have the bead apex, the chamfer, bead core. Tire makers are very reluctant to change anything in those compounds because they make such a small section of the tire, and the sustainability gain they can get by putting recovered carbon black there is very small, and the risk of actually risking any mechanical issues, delamination, is much too high. So we really have two strategy options for recovered carbon black in tires. And the difficult one really is direct straight addition into the tire, into into the compounds that typically use N600 type carbon blacks. So really we have two main compounds. We're talking about the inner liner and the sidewall. Which is actually interesting way where the industry is going with many furnace carbon black manufacturers, including Birla, Cabot, and also the transloading company Macrochem, doing blends of furnace carbon black with a defined recovered carbon black content. This is very similar to the biofuel you can buy at the local station. Here in Germany we have an E5 with 5% biofuel, E10 with 10% biofuel. For example, Cabot has presented a 550 carbon black with 10% recovered carbon black. So it's blended by carbon black producers, major transloaders, distributors, and Macrochem. The important thing is the blending only works before the pelletization, because the pellet of the recovered carbon black is more heavy than the pellet of the furnace carbon black. And if you just mix the pellets, then on a long bumpy road, it could be that in the big bag or in the silo truck, the recovered carbon black pellets will be underneath and the furnace carbon black pellets will be on top. So really, we need to pelletize the recovered carbon black into the furnace carbon black. The blends into each compound. So with a blend, really, we can go in every compound and put a small part of recovered carbon black with a defined performance, which is guaranteed by the reliability of the tier 1 producer, and they control everything along the supply chain. So tire makers from the carbon black makers, when the carbon black makers resell blends or resell recovered carbon black, they have, of course, more reliability than the recovered carbon black producers, mostly small companies themselves. So let's look at some sample formulations. One little gulp to smoothen my voice. This is from a very nice book which can be bought online, a PDF. Vanderbilt is a company doing tire additives, and they have a rubber handbook. This one is from 2010, so maybe there's a newer edition, but it gives you starting recipes, and then you can look at the recipes. Where is which type of carbon black, what are the other additives, and you get, if you want to compound your own rubber, or if you want to talk with a customer selling recovered carbon black, and you want to understand what kind of compound typically is used for a specific piece. So inner liner, we have butyl, we have halogenated because the halogen atoms are very big, and this adds to the airtightness of the inner liner to prevent flat tires. Sidewall is different. We have natural rubber, we have a little bit of BR rubber. In one case we got 600 carbon black, and the other case we got 500 carbon black. The PHR is a per 100 resin. So if the resin is 100%, we need to multiply by the PHR of the additive we put on top of the resin. And I think this gives a nice idea for inner liner and sidewall recipes. One specific example, and The examples, of course, the tire industry does a lot of work in the carbon black industry, but it is all very confidential and very rarely published. One of these occasions, Bridgestone Americas, Jamie McNutt, technical fellow of Bridgestone Americas, I think now retired, presented on the 2019 iTech presentation, comparison between Delta Energy Black and N660. Very nice results, I think, with equivalent air retention. So that is really the confirmation from a top tire maker for recovered carbon black. Now, how do we test the recovered carbon black for tire? And we first need to select the tire section, which determines what kind of rubber polymer is used, what kind of formulation is used. The tread is, as we've seen, 45% of the car tire. It's an important innovation area. Most of the tire innovation are on the tread, because the tread really contributes so much to rolling resistance. It contributes all to the grip, and this is really where the tire offers the value. Typically, recovered carbon black does not perform in the tread. I have seen some activated recovered carbon blacks who can work in the tread, but they're still not as good as a 300 type or furnace carbon black. The polymer to test in would be an SBR polymer, and we could use the standard for carbon black testing in SBR 3191. What we would do is a DMA, a dynamical mechanical analysis, with a tan delta diagram, and the tan delta is the ratio of the viscosity of the loss module over the elastic module, and then we can plot over the temperature. This is really, really rarely used for RCB. In fact, the diagram, I did this diagram, and I wanted to compare the carbon black, which was a 660, with a filler, which wasn't recovered carbon black. And the silica I only sketched, I didn't have data, but of course the silica and the dynamical mechanical analysis is much better than the 600 grade carbon black, and much, much better than the filler. I won't go into the details because typically for RCB this is the dream, but at the moment we cannot live the dream yet if the reinforcement properties are not even close to an N300 group carbon black. So what else? What is left? Of course, the inner liner and sidewall, which are chunky sections of the tire. Inner liner butyl. We have some indication, which I didn't publish, which came from now Circtec. Peter Tahar did that back then. Some indication that the density of the recovered carbon black particles actually helps in the air retention, and that recovered carbon black could be better in air retention than the 660. The sidewall sometimes is a mixture of N500 and 300 grades, and it can be potentially part replaced. Here, really, we have the natural rubber, butyl rubber, sometimes even EPDM. It's a very complex system because we have mechanical crack resistance, which is important, but also the UV protection. And for UV protection, the carbon blacks typically are higher structured, higher surface area carbon blacks. Now, closing thoughts on the recovered carbon black in tires. We're already 1 hour. I hope you guys still have time to see me through the non-tire applications and the closing. So for tire application, the tires are the most important volume and the only real circular business where you can say we can take a tire and we go into a tire again. There is two loops. The big one is, of course, the consumer tires, which is the end-of-life tires. What I recommend recovered carbon black producers to do is to look at the industrial waste. Every tire company makes faulty tires or makes compounds which cannot be corrected anymore. And this amounts to 5% of the world tire production. So this is thousands of tons. For one tire site, I have in mind it was 2,000 tons per year, and plastic almost 1,000 tons per year. So that industrial waste is a very important waste. What is interesting in the closed loop, here in the collaboration with a tire maker, we can know what is in there so that we can really select the feedstocks for the pyrolysis operation. Tire has a very long approval I would say collaboration time, because no tire maker will approve a recovered carbon black without knowing the company. And the approval time really is between 1 to 7 years. Pirelli told me they're really very, very eager to fulfill the 2025 goal of 3% recycled materials. They really want to purchase the recovered carbon black. They say 1 year approval time. But, it's difficult for a tire maker to have approval time in 1 year. A lot of work has to be done. Consistency, Starbucks strategy, important. The low-hanging fruits, solid tires, low production racing tires sounds like a contradiction. But the big problem of most of the car tires, the consumer tires, be it OE or aftermarket, the numbers are just too high, and recovered carbon black is not available in sufficient volumes. You might have seen Enviro and Michelin publishing about racing tires with recovered carbon black. Of course, not in the tread, but in the carcass. Now, a racing tire has a low production volume for a specific car, maybe specific race, so that could be a good start. Needs to be a very good recovered carbon black, of course. Tire-to-tire recycling. OTR tires, mining tires, for me, have really the most narrow composition. We have only Michelin and Bridgestone as major manufacturers, and they have pretty much the same contents in the tire. That is a very nice system to be parallelized. Eventually, we will require recovered carbon blacks with reduced inorganic content, because at some points the tires contain a lot of recovered carbon black, contain a lot of inorganic material from the recycling, and then we have to look at ash reduction strategies and technologies. I don't think this is required just now. Also, I think, in my opinion, there is no reliable inorganic content reduction technology for recovered carbon black there yet. I haven't seen any. It's really in the academic area, mostly acid base, and everything else is not proven yet. Mechanical rubber good applications. So let's look at that slide again. We're talking about extrusion profiles, belts and hoses, that kind of application. One key, and I'm very happy if we still have Achit Kumar from Cloud Compounding here, custom rubber. Now, a key market that is not a sector, so it's not an application sector, but it's more or less how the rubber industry gets their compounds. And in the consolidation and the recessions, many of the small rubber compounders have stopped rubber compounding and have actually outsourced the compounding to custom rubber compounding companies, of which Clovid are, I hope I pronounced that correctly, are one. And the main polymer here, because many of these custom rubber compounders are not really catering for the tire industry. There is Polymer Techniek Elbe PTE, who is also doing tire compounds. Some Dutch compounders do also tire compounds for Apollo Vredestein. But I think the majority of the custom rubber compounders don't compound tire compounds. The tire manufacturers do their own compounds for the sake of quality control. They do their own compounds. So here in the non-tire application, one of the big polymers is EPDM. And the main process might be extrusion applications. So that could be construction seals or even automotive seals. Although the big automotive sealing, body sealing companies like Cooper Standard, Meteor, and Standard Profil, they compound themselves, of course. Sheets, also extrusion. We might have solid or sponge. What is important to understand about the carbon black used here, it's a clean, structured, highly structured N550 carbon black. So why highly structured? With a high structure, we can avoid a die swell, which is like blowing up the compound going out of the extrusion. We have a big pressure difference from inside the extruder to outside, and we have the die swell, which is a problem because then the structure, mechanical structure of the profile cannot be maintained. And typically N550 carbon blacks are used to prevent that. Why clean? So for the sealing profiles, especially automotive sealing profiles, the outside sealing profiles, everything needs to be very, very smooth. The sealing profile is the first thing when you open your car door, you look at your sealing profile. It needs to be very, very smooth. And this is not really about the carbon black being gritty, but the so-called grit on the 326 mesh, which is about 44 microns. The grit is coming from the water and the salts in the water that are used for the pelletization. Or in the case of the furnace carbon black, another source is the quench water, the quench that stops and controls the furnace carbon black reaction. There's like 4 tons for every ton of furnace carbon black injected into the reactor is water. So that's a lot of water going in. If we have salt content in the water and later on we dry, that salt might crystallize and might be big particles, grit, that could be visible in those profiles. So purified water needed for the RCB as well, for the pelletizing, if we want to have a true clean extrusion RCB, and we need to mill as fine as we can. I think below 10 micron is fine. Everything below 10 micron is cost excessive for the milling and might only be required in coloring systems, for example, printing inks and coatings, industrial coatings. Biggest compounder is Hexpol, also focusing on sustainability with the Scandinavian culture, already using recycled powder, already using recovered carbon black, reclaim a number of sustainable and also bio-based materials. Hexpol really are the biggest in the world, the biggest non-tire rubber compounder. And they have economies of scale because, of course, they buy the polymers, they buy recovered carbon black and normal carbon black at high volume, and they bargain with low prices, obviously. I put Kreiburg as a specialized compounder. I would say Fluid, for me, is also a specialized compounder. And, you know, simple, cheap EPDM polymer. Don't know about the polymer prices right now, but when I was in the carbon black industry, the saying was the Hexpol EPDM compound is €2 per kilogram, and the Kreiburg compound is more direction €6, so much more specialized compounds. And the big volume compounds, EPDM, of course, are lower priced. Extrusion profiles, already mentioned, RCB should only be an inside compound. The visible outside compound is restricted to the clean 550 grades. Cabot, that was a Spheron range of carbon blacks. We can see again from Vanderbilt Rubber Handbook formulation. It's a composite, pretty much like a tire. So we have steel in there to maintain the shape. We have textiles in there. We might have sponge in there. It's a very elaborate system. And maybe if we recycle cars, the only things, rubber things we can recycle are tires and the body sealing profiles. All the other particles, all the other parts, rubber parts in a car are too small to be recycled. Conveyor belts, for me, are pretty much similar to tires. We have the outside, which is like a tread, and we have the carcass with steel and textiles. RCB really is limited to the carcass and to specialties. This one recipe is a friction compound. If we want to have high friction on the outside, this is a friction compound featuring 550 and 770. I haven't seen for a long time. I think nowadays that should be 774 and 772 carbon blacks. But both are like in the realm of being able to be replaced with recovered carbon black. Airport conveyor belts use carbon black as well, could use recovered carbon black. Hoses, there's really a lot of hoses formulations in the Vanderbilt rubber book. So air conditioning hose, hydraulic hose, power steering, automotive fuel hoses. They're all featuring the 3 big groups of semi-reinforcing carbon blacks, the 700, 600, and 500. And the more we have 700 and 600, the easier it is for the recovered carbon black to replace. The 550 as a higher structure carbon black is a little bit more difficult to replace with recovered carbon black. Wire and cable jackets, this is a heavy-duty neoprene jacket, also against 700 and 500 type of carbon blacks. Much of the wire and cable jackets, a little bit like body sealing. Body sealing on cheap cars is going from rubber to TPE, thermoplastic elastomers, or TPV, thermoplastic vulcanizates, for cost reason. But when you have, let's say, the Bentley and Mercedes and BMW, where you have the nice door sound, this is still a rubber profile. But the same is going on in the wire and cable industry. There's a lot of TPEs used, sometimes also used with halogenated polymers for the resistance, and rubber is being replaced with those specialty polymers. Closing thoughts on recovered carbon black and mechanical rubber goods. So I think custom compounders like Clowit in the webinar offer the best access and the best way of a supply chain of sustainable material like recovered carbon black into the non-tire rubber market. Because the non-tire rubber market, the mechanical rubber good market, is very segregated, so there's so many applications, the volume might be quite small as well. EPDM is the main polymer, 550 and clean 550 are the main carbon blacks. Automotive sealing market is the biggest, by far the biggest sector. Here only in the inner profile, not in the visible profile opportunity for the recovered carbon black. We also need to do a focus on simple applications, because in some applications we, for example, have very expensive rubber, fluorinated FKM rubber, where recovered carbon black needs to perform very highly, and those companies, they don't want to have any industrial waste if things don't go well during production. So recovered carbon black, for the time until consistency has proven, should really stay on the simple application. We got 3 months approval time, typically for non-tire rubber. And again, consistency. The Starbucks strategy is super important. Some interest of the manufacturers of the larger goods, like conveyor belts, might be open to closed loop industrial recycling, where the pyrolysis company or recovered carbon black company takes in industrial waste, which can be led back into their own products. Okay, so we are 30 minutes over the time. Now I invite you to ask me questions. Thank you very much for bearing with me so long. So actually, many of the leading companies still don't do it. I don't want to blame anybody or pinpoint on people, but some of the really big names don't do it. Others, simply don't shred in-house, and then it's a question of outsourcing the control to somebody else. But the biggest granulators, Liberty Tire in US and Genan, with sites in Europe and in the US, they don't have a means of selecting tires, so they cannot actually promise you that the granulate you buy from them is a certain mix. And so this is really difficult, and this plays to the favor of those recovered carbon black producers that are taking in the whole tires, that are selecting the tires, because you can only really select the tires before shredding and granulation, and that granulate and shred themselves. Of course, this has a lot of running costs. You need somebody selecting the tires, and by any means, by type or by measuring, like Black Bear Carbon do. And then you need to have the capex to buy a shredder and granulator, and this, we're talking significant millions of euros for a meaningful shredder. So not everybody is doing it yet, but I advocate strongly for it, because if you don't control what is going in the pyrolysis, how can you have any hope of a consistent output recovered carbon black? Some people, I mean, clearly some projects are, for Alberta, Edmonton in Canada, they only have mining tires. And then the case is very clear. You don't need to separate. You take just the mining tires, which are very, very consistent. The trouble really is where you have a mix of passenger and truck tires, especially in Europe and the States and China, with very varying degree of inorganic content. And again, I'm so glad that Solvay is in the webinar. The varying degree, increasing degree of precipitated silica in the tires needs to be controlled on the side of tire recyclers by pyrolysis in order to make recovered carbon black. The alternative test is just the standard testing. If you test in rubber, you would start with normal mechanical testing. So you need to vulcanize the rubber, make strips, and just look at tensile strength. You always need to run a benchmark system. So, for a really good recovered carbon black, you compound the same system with a 660 furnace carbon black, and that is your benchmark. And then you measure the recovered carbon black. Same as the Fourier transformation rheology. You don't do a single measurement because it's very difficult to compare. You always choose your system, choose the polymer, and then you do the same recipe for recovered carbon black and a furnace grade carbon black. For a good one, I would choose 660. For not so good, you can choose a 772 or 774. And yes, I agree to you, the availability of that test is not very good. Basically, we're talking continental. I know one lab in Germany, but now I have questions from US people and they want the same test. And I'm in the process of getting that from the US, and it's not so easy. And also, you might think, because this is now an ASTM test, which was approved by ASTM, so it was not vetoed by Michelin and Bridgestone, but as we have seen in their call to action, the rubber testing completely was excluded. And that was basically for the reason that Michelin and Bridgestone, they work together. In my conference, the Recovered Carbon Black conference, they even confused their company. It was so funny. They were working like one company, but they did not share the approval process rubber testing to each other. That would have been, a violation of the antitrust. That remained confidential. I wonder what the RCB rubber project, meaning Michelin and Bridgestone, whether they will embrace the continental test, which I hope they do, because then we can say, okay, this is a test everybody agrees to, let's do it. It's expensive, okay, but this is a quick test we all want to do. That would be the way forward. So this is about dispersion, but it's also about vetting of the polymer. And because let's say the compounding process for the rubber has a specified time of the compounding. During that time, there needs to be polymer all around the recovered carbon black. And simply when it is pelleted, you can get twice as much recovered carbon black into the polymer. And so that would be my explanation, that the pelleted recovered carbon black actually offers you a higher tensile strength because you get more recovered carbon black to work. If you have the fluffy, it's very difficult for the rubber polymer. It's still very viscous, even though the compounding temperature is 130 degrees, which reduces the viscosity a little bit. But then again, we have that cycle time for the internal Banbury mixer. During that cycle time, we need the polymer to be all surround all recovered carbon black particles. And that is very much more difficult to do with the fluffy than with the pellets. You can just get more recovered carbon black really into the polymer. And so the reason I'm going like this is For you, it's impossible to use that REACH registration because I don't think that all the parameters are true for recovered carbon black. Of course, the consortium sells you the license, which I think is quite expensive, but it is up to you to prove that you are entitled. And they say that on the website as well. And so I looked at it very, very deeply. I don't think really recovered carbon black can fulfill the boundary criteria defined. The only carbon black that you could match is the oxidized carbon black, which only has 80% carbon, but then it has a lot of oxygen instead of the inorganic content in the case of the recovered carbon black. But then it goes on and on and on about the micronodal size and things really you don't control in the recovered carbon black. So it is unfortunate if you bought the REACH registration for the furnace carbon black because I don't think it can hold, I don't think you are entitled to use it. What you would need to do is you need to actually do an inquiry dossier with ECHA, which I'm doing for a client in Europe at the moment. And it's really, really difficult because you need to get really a lot of analysis data. And based on that analysis data, as I said, if you're close to what CircTech and Alpha Carbon have registered, then they make that link and say, yeah, we mapped you to the CircTech REACH number. And then you can contact them and pay them. But it is only after that REACH inquiry. So the first step is you have to do the REACH inquiry dossier. And then REACH will tell you, yes, you can use the CircTech REACH registration. Even the European Chemicals Agency who is doing the REACH, yes. And that, of course, is a trouble. And then really we have to know what is right. And what is right, of course, is that we go with the CircTech Alpha Carbon REACH registration. I think, in the presentation last year, Robert Harper explained they put 3 recovered carbon blacks in. One was the former Carbon Cleantech Pyrolix. One was obviously the Alpha Carbon, and one was the CircTech. So 3 different processes to have really a breadth of composition difference. What on the REACH registration name, the name is now they changed that only recently. Is now 2-stage pyrolysis. Amorphous carbon silicon dioxide recovered from 2-stage pyrolysis of spent tires, which of course is not the case for actually one of the samples they put in, the Carbon Cleantech sample, that used to be a batch kiln. But they just called it, they added the 2-stage pyrolysis. Of course, the two-stage makes it easier to have good conditions for the oil and for the recovered carbon black, and still have in the stage 2 produce a very dry, low volatile recovered carbon black. I don't know, honestly, and I'm still wondering, who that TSCA anonymous registrant was. I don't know, because any of the 3 big companies in the US, Boulder Industries, Delta, and now Ecolomondo, Canadian but with a US project, they would have a strong interest of getting their regulatory status solved, right? So difficult to tell. Maybe I should, we should call them up. I don't know. In Europe, it's much. I think now the step has been taken, and the only thing people like Vishal have to do is to get the inquiry dossier, and then it should be on rails. And then, if they map you, Vishal, if they map you to the carbon black, furnace carbon black, you say no. Look at the composition. We need to argue with ECHA. And make sure that we go to CircTech Alpha Carbon. Actually, Michelin and Bridgestone, when I worked with them on the call to action, that was their fallback position. And they required at the beginning that all recovered carbon black would have less ash content than 19%, because they wanted to be sure that if everything fails, and they did not know about the CircTech REACH registration, so the only way forward was to use the furnace carbon black REACH registration. And they said ash content 19%. But I can tell you for sure, I analyzed it very deeply, maybe like Klaus did as well. And the 80% carbon is not the only requirement for using the CB4 REACH furnace carbon black license. And also, I mean, one other thing I'm thinking about, Vishesh, is, you know, trying to sell to Europe is based on sustainability credentials. But this morning in the Carbon Black World, I asked the audience, what is sustainability? Is an Asian-produced recovered carbon black from European tires sold back to Europe, is that sustainable? Like the tires go to India and then the recovered carbon black goes back to Europe. That's a lot of transport. And of course, it would be a better sustainability situation to take a Indian tire feedstock. I know the infrastructure is not there, but to take an Indian tire feedstock and sell, remain within the country. The Indian tire makers, MRF, Apollo, they go hugely into sustainability, like all the global tire makers, and that is more like a sustainability strategy, perhaps even a higher value, because the lower carbon footprint represents a value for the tire makers. Because I think, you know, India for recovered carbon black is a big country, and that industry is much more established than in Europe. It runs more on the economy and the recycling strategy than the sustainability and product strategy in Europe. But that, you know, that is the big opportunity for India. This morning I said it's a big opportunity for China. So now I'm saying it's a big opportunity for India. It's true. I mean, China, 10%, I think, of the Chinese tires are recovered by pyrolysis. India, I think it's the same, is it? 10%? 70. Oh, wow. Okay. So you know, and then it would be fantastic to have more recovered carbon black produced, meaning the tire is controlled, the tire pyrolysis is controlled, and then the refining. I know there's big companies just buying all the raw recovered carbon black, but if somebody doesn't sell recovered carbon black, they don't control the tires, they don't control the pyrolysis, because all they want is the oil. And then it's very difficult to make a high value product of all those raw recovered carbon blacks. And the milling and pelletizing is not sufficient. Probably you need to go back into a pyrolysis to make a robust system. You know, and that is good. Just be careful that you're not infringing with the Black Bear carbon patent, because they have the patent of sorting the tires according to the silica content. I'm sure they want to sell you a license too, but let me, I think the sulfur is 1% on car and truck tires. I think in truck tires there's 2% zinc oxide versus 1% in the car tires. So you have more zinc oxide in truck. But really the major chunk, the biggest chunk of the inorganic or the so-called ash content really is the silica. And this is, I mean, Vishesh, for you it could be so easy. Just don't take any European tires because they got the silica. Yeah, I think US is a halfway house in my understanding. It's like not as much as in Europe, but also, you know, it's getting up. So, I mean, the tire control really is super, super important. And don't get me wrong, without the pyrolysis, we cannot do anything. But my point is the pyrolysis is not the only thing controlling recovered carbon black quality. I mean, for that, the answer is yes, but I mean, you're talking about a second pyrolysis, right? And then if you need a second pyrolysis after your first pyrolysis, maybe it would be easier to replace your first pyrolysis with a kiln that is working better. And we've seen the trend to several stages, so 2-stage or even 3-stage kilns. Circtec themselves have a fluidized bed kiln, which is perhaps the highest efficiency of the heat transfer. But there's a clear trend to 2-stage pyrolysis. If you do it like Black Bear, 2-stage rotary, or like others like Alpha Carbon, there's 2-stage auger kiln, or even 3-stage, as some companies have. That definitely helps. Just buy the same kiln again. You know how to run it, how to maintain it. Just buy the same kiln again if it is working for you, right? What I found interesting, there's like as for kilns and rotary kilns, because the rotary kilns, they're sold for everything, and they can also be used for pyrolysis. And there's now a new kid on the block, the company 1 June. And they're like have a European base, but my understanding is they're manufacturing in China, and they're really going into pyrolysis. They're in the Azur Association in Germany, which is about the recycling of German tires, and they're very, very active on recovered carbon black as well. But I mean, up to you. Would just buy the same kiln again if you're happy with it. Okay. Thank you very much, everybody, for joining this webinar. Have a great afternoon. Any more questions, please just ask me, and I hope see you in the next one. Thank you.